Recording the cloud. All right, welcome in. Good evening. We're gonna go ahead and get it started. So this is Women Who Code Python. Welcome everyone. Our mission, we are a global nonprofit dedicated to inspire women to excel in technology careers. We have different goals. We want to empower people, women with skills for professional achievement. We want to educate companies to better promote and retain and hire talented women. We want to build a global community where networking and mentorship are valued. We want to develop role models and support this generation of engineers. Our code of conduct is that we are an inclusive community and we are dedicated to provide empowering experience for everyone who wants to participate and support our community. As long as you support our goal, regardless gender or anything, any orientation, you are welcome in to join us. We have different tracks. We have front end, we have blockchain, we have Python, which is us, we have mobile, we have cloud, and we have data science. We always want to thank our sponsors. We couldn't do anything without them. And this is McKinsey and Company, Python Software Foundation, the Home Depot. Oh, I probably forgot to remove the part 2 because it was part 3. So tonight is part 3 and the last part of the PySpark series, and it's by Aida Martinez. So if you didn't know her from before, just gonna a really quick overview. She's a senior data engineer and software developer with more than 10 years of experience creating data solutions and web applications. She works at Use Analytics, where she applies her data engineering skills to build fast and reliable data pipelines using Python, AWS, and Apache Spark. She has a major and Master of Science in Analytics from Georgia State University, where she was graduated research assistant of the Institute of Insight. In her free time, she can be found practicing yoga, traveling, and learning new cloud and open source technologies. So I'm gonna go ahead and take this. And stop sharing. And we're gonna pass it through Aida Martinez. Thank you for joining us tonight, Aida.
Hello, everybody. Happy Wednesday. Can you see my screen?
I can see it.
Okay. So I just posted the link to the third part of the workshop. So you can go ahead and click on it. The first thing you need to do is when you open the link, you can go to File and then save a copy in your drive, please. So you can edit and do changes on it. And let me know when you are all done, we can start. In the meantime, I will do a little bit recap about what we are doing. So in this workshop, we have been trying to create an ETL to extract crime data from different cities. Between them are San Francisco, Austin, and Chicago City, and there are data about report incidents of crimes that were committed during 2018. And you can see that reference at the end of the notebook.
I just link again. I think it was not, they didn't get it, but I just resend it.
Okay. So on the first part, we basically covered data extraction, and we saw how to read some data sources, apply schemas, and handle corrupt records. And then on the second part, we did several data transformations. And right now, for the third part, we are going to start by doing some filtering, aggregations. We are going to see how to integrate this with pandas and doing some joins and lookup tables. And finally, how to write data to files and a little bit about repartition and coalesce and some best practices at the end. So are you all able to see this workshop, the third part? Or are you having any problems with it?
You can either speak or you can send us a message in the chat. Okay, Sunita said she got it.
So are you all able to see it, to see the workshop and to save it, a copy in your drive? Okay, so so in your copy, if you can go ahead and start running these 4 cells over here. You can run it over here, each of them, or you can click here. For example, click on runtime and run all the cells before. So basically this one will be installing and setting up a Spark, and we'll just download it. One of the latest versions of a Spark. It will set up the environment variables, and then it will import PySpark. That is the one who is going to add PySpark to the sys.path at runtime, and it will initialize it. And finally, it will create a Spark session, and where our cluster will be locally. And this get or create, it will either create an existing session or create a new one. In this case, it will create a new one. So run these 4 cells, and then we're going to start with the new part. So in the second part, we did a lot of transformations tasks. Between those ones, we added new columns from missing fields, like the row ID, incident year, and incident day of week. We also added a new column with the name of the city, so we can append all the 3 data frames later. We did some casting, especially string fields to timestamp with the same format across all data frames. We did some casting as well from Boolean to or integer to string type, and we renamed some columns to match our appended data frame. So you can find this table where I have the original names on each data frame and the final data and how it should look like the final one when we append all of 3 together. So if I go here, then this is all what we did last week. And we're going to start from this checkpoint. So you will have some rows where you can get the data just as we transformed it last week. And we can upload this file and then read it into our San Francisco, Austin, and Chicago data frame. So you weren't here before, this is the way that you can read CSV or any file, you define a format and you can define several options. One of them is define whether it has a header or not, and whether it inferred the schema or not. And this inferred schema equal to true is true by default, so you don't need to really define it in here, but it's a good practice just to put it there so you remember. So you can go ahead and you can run these 3-4 cells and make sure that everything, it doesn't throw you any errors or anything. And please let me know if you are having any problems. So while these cells are running, I'm going to explain a little bit about how concatenating and appending rows. So how you previously learned, data frames are immutable, and that means that once they are created, they can be changed. So to append to a new data frame, we use the method union, and we use it on the original data frame along with a new data frame. And you can, for example, use it you can chain methods. So you can define a data frame dot union, and you send another data frame as a parameter, and then you can use another dot union and send another one. And what this will do is to do a union of all 3 data frames over here. If you want to know more about the union method, you can right click in here. This is a link to the documentation. And it's really important that you know when you're doing a union, you must be sure that they have the same schema and the same number of columns. Otherwise, this union will fail. And if we see here, well, you will see only San Francisco here, but we are going to do an aggregation soon. So if you want to find distinct values, remember that Spark uses pretty much like the SQL syntax. So you can do, for example, use select with a distinct. So in this case, for example, if we want to analyze the values of the resolution field, then we can select the resolution column and then use the distinct methods to show the distinct values that this column has. And you can see we have some nulls, we have clear and not clear. So as you can see, if we want to see that we have all 3 cities in our appended data frame, then you can use the same. You can select the city column, and then you can apply a distinct method. And you will see that we have all 3 columns over here. So how you handle nulls? You can see here in the resolution ones, we have a null. And sometimes it's really useful to represent in a different way missing or empty data in your data frames. And Spark has a lot of methods. It inclusive have a .NA subpackage on the data frame. And they can do a lot of things with your null values. So you can explicitly drop or you can fill them with another value. So for example, if we want to fill the nulls in a resolution column with a value not clear, then you can do a crimes.na, that is the subpackage, .fill. And first, you are going to put the value which you want to fill in the null. And then in the subset, you are going to define all the columns where you want this to be applied to. In this case, we want to have it applied just to the resolution, but in other cases, you might want to apply it to several columns at the time. And then if we do another select, this thing, we can see that we don't have any null values anymore. So you just have clear and not clear. And you also have other methods like the drop. We just remove rows that contains nulls. So instead of fill, I put a drop, then it will just remove the whole row. And you can define, for example, if you define just drop without any parameter, it will just remove the entire row. If you use drop with any, that means that it will drop any row on which the value is null. So you can find a lot of different NA functions on the documentation over here. You will find the drop with the parameters, and you have this how, can be any or all. And then you can find the fill and how it works with the different parameters over here. So some other methods that are really useful when you are trying to analyze data with Spark is the filter and where methods. Basically, you can use either of them. They both will perform the same operations and basically accept the same argument types when used with data frames. So these two rows are basically equivalents. So they will give you exactly the same result. So you can use the one that you feel more comfortable with. And in this case, we saw last time that when defining a column, you can use the call method, or you can just put everything like in a string. And you use the backtick when you have a column name that it has spaces in between. So in this case, we want to filter all the records where incident day of week is equal to Monday. And if we go over here, we will say all these records are from Monday. So sometimes you might want to put multiple filters into the same expression. And it is possible. I mean, you can use the chain methods. And for example, in here, you can continue putting another filter, for example, and it will work. But it depends. For clarity, usually I do it just one at a time. Because otherwise, when you have an error or it fails, then it will be more difficult to find out where the failure happened. And it doesn't matter if you use chain methods or you just do it separately. Spark automatically will perform all filtering operations at the same time, regardless of the ordering or how you do it. So if we continue, so filtering and where clauses, they are really useful for doing analysis. We can do some, when you are creating ETL, for example, there are different challenges. For example, in this case, we have cities. Each data frame for each city use different values to describe incident categories. So we're going to explore data for the 3 cities to understand, in this case, about robbery information. So in this case, we're going to filter all the incident categories that it contains robbery. And then we're going to select only the incident category and the city. And we get the distinct values for it. So you can see this is pretty similar to a SQL. And in this case, I'm telling it here truncate equal to false means that it's not going to truncate this string. It will show me the complete string when showing up the data. So right now, I will give you a couple of minutes so you can go over this exercise and replace all these values containing robbery to the same value. And I will show you, if you weren't here last week, I will show you how we do a replace over here. So this is the way you replace. You have the value that you want to, the old value, the new value that you want to replace, and then the column on which you want to apply that replace. So go ahead and I will give you like 5 minutes to do that. Let me know if you have any questions. Okay, so everybody doing okay? No questions so far? Okay, so your solution, it should look like something like this. And you were able to test your solution, it should be passing.
Any question, anyone? Any help that you need?
Okay, so continuing here, we're going to assign to a new data frame all the incident categories where that it contains robbery. And in this case, all of them should be equal to robbery right now because we already replaced it. We also have, we can do aggregations. And in these cases, Spark also allows us to create groupings using the group by method. And you can see some of the aggregations are here, and you have the link to the documentation for all of them. So what we want to do is to create a summary of the number of robberies per month. And our data frame, it must contain 2 columns, the month of the incident and the total number of robberies. And we're going to use also the month function to get the incidence date month. We can also sort rows, and you can see we have 2 equivalent operations to do this. We have sort and order by, and they both work on the same way. And they both accept the column expressions and a string, as well as multiple columns. and the default for the sort will be in ascending order. So in this case, if we take our robberies crime data frame, we can select the month for the incident date. We can assign an alias. These aliases are the same as a SQL. So just to rename your column. And then we can group it by the month. And we can do a count over it, which will going to rename this count column with robberies. And we're going to order by month. So if we run this, you will see that we have the month from being 1 January and 12 December. And then this is the count of the number of robberies during those months. And as we saw on the query above, counting is a little bit of a special case because it exists as a data frame method. And for this, usually we prefer to use the count function. So you have a count, it can be a function, or it can be a data frame method. In this case, it's a data frame method. But if we want to use like the count as a function, then we need to specify it inside the aggregation method. So you will see that we can pass on the aggregation. For example, we can specify a column, or we can define an asterisk over here. So this function over here, you can do it only when you are using the aggregation method. This is not possible if you use the count method over here. So this is the difference between them. And inside an aggregation, you can define any function that you want. But basically, this query will do exactly the same that we are doing above. So there's two different ways to do the same. So after doing this aggregation, for example, sometimes we might want to visualize the results and want to do like a dashboard or bar graph, etc. And right now, I don't think PySpark has like a visualization tool on it. So one of the common patterns is to perform, for example, really large scale ETL work with Spark, and then just collect that result and then leverage pandas to manipulate it further, or in this case, for doing visualizations. So we're going to convert our Spark data frame to pandas. There is a method called to pandas, and then we can use matplotlib to visualize this data. So in this case, we only use the data frame, and then we call that to pandas method, and this will be a pandas data frame. Then we can import pandas and matplotlib. For example, we can create a visualization with the data. When we're going to sort it by month, we're going to define the month on x-axis and robberies on the y-axis. And you can see this is a bar graph. And we can define the labels over here. And we can see the number of robberies per month. And also, to be more explicitly specific about the sort direction, we can use the as for ascending and des for descending functions. And this allows you to specify the order in which a given column should be sorted. So right now we haven't added the city for our aggregation, so let's do that. And we only need to add the column city in our select, and then we added it as well on the group by and in the sort. So we can have here our city, the month for each of them, and the number of robberies. And you also have some method like, for example, ascending null first to specify all this about here. And you have the links to the documentation. And with this one, you specify where you would like your null values to appear in an ordered data frame. So you want the nulls to appear at the beginning or at the end of the ordering. So now I will give you a couple of minutes so you can do an aggregation by day of the week. Let me know if you have any questions. Okay, everybody doing okay? So if you want to order and aggregate by the day of the week, this is how it should look like. You should be able to select your city, the incident day of week with an alias if you want to, and then group it by the city and the day. In this case, you can see we are using the same alias over here in the group by. And then you can do a count and a sort of the city if you want in descending order, and the day in descending order as well. And you should be getting this over here. There is the test code, so you can test it out. So we also have joins and lookup tables. And in this case, by default, Spark does an inner join. And you can use lookup tables that are normally small historical tables to enrich new data passing through an ETL pipeline. So in this case, our monthly and daily aggregations are interesting, but they are flawed in the sense that we're comparing the raw numbers of robberies instead of the per capita robbery rates. So in this case, let's read a data frame called city data, which contains the estimated 2018 population values for all US cities for populations of at least 100,000. And then we're going to calculate the robbery rate using the following formula. There will be total robberies over population multiplied by 100. So if you run these cells, you are going to get the city data. And then on this one, it's going to read the city data into this data frame called city data. And you can see the columns. We have the 2018 rank, the city, state, the estimate, the 2010 census, and the change. So in this case, we want to create a new data frame called robberies monthly rates. So we're going to use our robberies month city, where we have the month per city, and we're going to join it with our city data. So in this case, the first parameter is the second table that we want to use, and you can define an alias over here. And then you need to have the keys that we're going to use for the join. In this case, we're going to use city and the same one on the second data frame. And then you can create a new column that will be called robbery rate. And this one will be the formula that we had before. So it will be the column called robberies over the column called 2018 estimate multiplied by 100. And from here, you can select a specific columns. In this case, for example, you define this alias, then you use the same alias on the select statement. So you can call a column where rob.city and then city.state and going on all the columns that you want in your final data frame. And if you show it over here, you can see we have the city, we have the state, we have the month starting from December to January, and then we have the number of robberies and the monthly rate over here already calculated. So on the above result, you can see that, for example, in here, we defined twice the column city. It was coming from different data frames, but the name was exactly the same. So sometimes when the name is equal and you want to do a join, you can define just the name, just the string over here without defining the two data frames. So that's one thing that you can do. So if your keys to join have exactly the same name, then you just define it on the second parameter. And you will get, you can see you will get exactly the same result as the query above. And we can use a Spark SQL to do the same. And in this case, as we saw last week, you can define a temporary view. So you define the name for the view, and then you can create a view for the robberies month and for the city data, and then you can define an spark.sql over here and define your old SQL inside. So this will be like a normal SQL that you do in your database, and you will see we can do the select from robberies month city view over here. We define an alias. You can do a left join with the city data view with the alias city, and then we will join it by the city column in both data frames. And this will return you exactly the same result. So there are different ways that you can do the same, and you should choose the one that is more comfortable for you. So now I will give you a couple of minutes so you can join this city data with your daily robbery data frame. And your final data frame should have the following columns. So let me know if you have any problems or you have any questions. Okay, so if you already work on it, your query should look like something like this. You should have the robberies day city. You can define an alias if you want to, and then you can join it with the city data and specify just the city column because it's the same name in both data frames. And then define that daily rate over here with the robberies column over the 2018 estimate. And you can select only the columns that you need to and order by the city and day. In this case, we are ordering in ascending order. So you can do as well in descending. But I think this one didn't ask specifically for descending, so you should leave it just like that. And then you can test your solution over here. It should give you these same results. And finally, we're going to see a little bit how to load these results into a file. Basically, the core structure for writing data is as follows, and it's really almost the same pattern that you follow when you are reading. You have to define a format, a set of options, and you can use partition by, bucket by, sort by, and finally a save method. And instead of using a data frame reader, we have to use the data frame writer. And you will see, if you click over here, you can go to the documentation and see all the methods that are available for the writer. And we can use, so you can use directly the data frame.write. In this case, data frame.write, define your format. They can be any of these formats over here: CSV, JSON, Parquet, ORC, GDBC, or plain text. And you can define any number of options with the key value and the save method, and define inside here your path. Where do you want to save it? And this is only on the case where we want to save to a file. And we have different save modes. We have the append that will just append the output files to the list of files that already exist on the location. We have the overwrite that will completely overwrite any data that already exists in there. And we have the error if exists, that it will throw an error of failed the write if data files already exist at the specified location. And you can also use the ignore. So if data files exist at the location, do nothing. So it doesn't overwrite, it doesn't throw an error, just ignore it. So you have a variety of options for writing data, and especially when we are writing CSV files, we can use some of them like defining the header equal to true, and the mode, we can use the override, and we always define the format, either if it's CSV, a JSON, a text file, etc. And in this case, like we are working on Google Colab, then this is like we are in a, that is like you were in your local computer. So we're going to define a path. And basically this path is a folder. So it's not the name of the file, it's just a folder name. So if I define this and I run it, you will see in this file tab over here that you have a monthly data folder. And inside this, we have all these files. So basically it will create, it will divide all the files in different parts over here. So the number of files or data written is dependent on the number of partitions that we have on a data frame. So our partitions is like the number of nodes or tasks that were or data were divided when they were sent to the Spark nodes to be executed. And in this case, each partition writes one file. So writes the results from one of the nodes. In this case, we can see how many partitions this file has by invoking the RDD get non-partition method. So in this case, if we apply this method, we will see that we have 36 partitions. And if you see over here, this starts on 0 and go all the way down to 35. So there are 36 files. So in this case, you can go inside one of them and you will see that you have only one row in here. So now I will give you a couple of minutes so you can save the daily rates data frame and you check the partitions that we have over there. So let me know if you have any questions and I'll be here. Okay, so let's see how it should look like your queries over here. So you save your daily rates, you can write it to a CSV, and you can have your option, the header equal to true, and your mode override. And in my case, I saved it to a folder called daily data. So if I go over here, I will see all my files, and I have 21 of them. So 21 equals to the number of partitions over here. And if you do as well the one that writes to JSON format, you will see that the only difference is that instead defining a format with CSV, we can define it with JSON in here. And if I go to the monthly data JSON folder and open up this one, you will see this is a JSON file. And this is on JSON format. So you can see that there is one file created per partition, and the entire data frame was written out to a folder. And you will see that we currently have one JSON object per file. And in the case on the CSV, we have one row per file. So over here, we need some of the methods that are really useful. For example, when we want to either repartition or coalesce, and this is, for example, repartition usually incur in some performance, regardless of whether it's needed or not. So for example, you will do a full shuffle, and a full shuffle of the data means that we just move the data all around between the partitions. And that will give you a really bad performance. So for example, you should only repartition when the future number of partitions are greater than your current number, or where you are looking to partition by a set of columns. So for example, in this case, if we go back to our original data frame crimes, This one has more than 500,000 records. And if we get the number of partitions over here, we'll see it has 6 partitions. So in this case, if we want to repartition, we need to do it with a greater number. And I can do my data frame dot repartition, and I will define a greater number, in this case 10. And if I get the number of partitions, I will get 10 over here. So if we write this to a folder, to a crimes data repartition, you will see I have 10 files over here. So when they were, so I should have more than, well, this is too big to be showing here, but now all my data will be repartitioned in more files than before. So repartition, you use it just when you want to create more partitions, not less. And or coalesce is used to combine partitions. So in this case, for example, if you use coalesce with a number greater than the current partition, like we did before, or to do that repartition, the data frame method will have no effect because it's used just to combine partitions instead. So if you remember, all the files that we saved before, we have 1 row per file. For example, in that case, we don't want to have that many records over different files. So you can do coalesce in that case. In this case, I'm going to use this same data frame over here, the one that I did repartition to 10, and then I will do a coalesce, so I will get it back to where it was before, to the 6 partitions. So if I do that and I write it to crime data coalesce, you will see crime data coalesce, you will see that I have over here 6 files or 6 partitions. So now we'll give you a couple of minutes so you can go ahead and use the coalesce method to reduce the partitions to 1 on both of our data frame, the monthly rate and the daily rate. So we can have only 1 file instead of several ones. So let me know if you have any questions or you encounter any problems. Okay, so if you already made your coalesce over here, this is how it should look like. You can do a coalesce of 1. And then when you send the write statement, in my case, I send it to a monthly data coalesce folder over here. And you can see I have only 1 file. And this 1 file contains all my 36 records. So I can see that 36 records over here. So sometimes you will need to do a repartition or a coalesce depending of what you really want. Or for example, if you are live with a lot of small files, that will impact the performance of your ETL. So a summary of both of them, usually repartition will create new partitions and coalesce will use existing ones. So it will put all together. And repartition will do a fault shuffle. So it will reorder all your data and put it in different partitions. And coalesce, it will just do a partial ones. So in performance, coalesce is much better than doing a repartition. And repartition will do a equal size partitions. So if your data frame, for example, have 10 records, then we have 2 partitions. Each partition will have 5 records in it. And coalesce, it will be have different size partitions. And usually this can happen because you are trying to reduce the partitions instead of adding more. So probably you will get, it will just do like a union of different partitions. So you don't have, you will have different size on each of them. It doesn't shuffle all of it again. And you can also write to databases. In this case, we can control parallelism with repartition and coalesce. And in this case, when writing to databases as well, we don't have, we can do observes. They don't exist, so observes are not supported in the core Spark. So in this case, you have usually for doing an observe, you usually have to truncate first your table and then load everything again, or doing, for example, or your transformation on a Spark, like doing left joins, doing a lot of partition by, doing rank over, so you can replace that data and for updates or anything else that you need. And this is an example on how to use the write to a data frame using a database in PostgreSQL. So you will use your data frame.write, will define the format at JDBC. Then you can define the URL. This is like the endpoint to your database. And you will define a DB table. Usually on your DB table, you define your schema as well. So you will use a schema.table name. And finally, you have a user and a password that you need to define. Sometimes in the URL, for example, you can add your user and password, but I don't recommend it because I have had some problems with it, in which Spark doesn't understand the URL over here, and especially if your password has some special characters, then it will parse it out wrongly and it won't connect to your database. So it's preferable that you use the user and password options over here. And then you can use the same mobs that we talked about before. They can be append, override, if error, and etc. And then just call the save method. So finally, so we do a little bit of summary of best practices. So it's recommended that you use the Spark data frames. They are already optimized and therefore are also faster than RDD. So RDD, they were, or they still are like the low-level API for Spark. Spark data frames are the high-level structures. But it doesn't matter, just still when you are using data frames, they basically underneath they are get mapped to an RDD. So it's the same thing. And you can see the performance of RDD, especially on Python, is really bad. So it's better just to use Spark data frames. And you can see some information in this blog as well, if you want to go a little bit deeper. So when defining schemas, we really want to define a schema prior to reading in for data, and it would depend in our use case. So for example, when I want to read a JSON file, And sometimes I will have like 100 attributes, but I only need to read 50 of them. Then defining a schema will be really helpful, because I will define a schema just with the 50 that I want, and it will read only those. And when reading CSV or other more structured files, then it's useful to have a schema definition if you have a really big table, like with millions of records. Because in that case, Spark won't do 2 passes. Usually when you are inferring a schema, Spark do 2 passes, one to infer the schema and the other one to read the data. So in this case, if you have a really big table, it's preferable to define a schema, so Spark will do only 1 pass to read the data. If you have a really small table, then it doesn't matter really. And if it is going to be more the work that you are going to do to define a schema, then it's not worth it. Also, don't call the collect method on large data frames. When you are calling the collect method, you basically drag the data back into your application from the nodes. So each data frame element will be copied onto your single driver program, and it can run out of memory and crash. So it's not a good idea to call the collect method. Then you also have available the catch method. So you can do catch data to improve query performance. And without catching, basically Spark reads the data from its source again after every action. So for example, if I read my data frame, I do a count, and then I do another transformation, then on the next in the transformation, Spark will read again my data. And in this case, for example, you can see that if I call, for example, this count over here, I will get, for example, 46 milliseconds. And then if I do a catch before doing the count, I will get a slight, well, in this case, it doesn't, sometimes it shows more, but it should usually be much better. And we also saw on the last workshop how to use user-defined functions. And especially when you are using them, you can do custom transformations. And in this case, the Python process of doing user-defined functions is really expensive, but the real cost is in serializing the data to Python. So this is really costly because it's expensive computation, and because after the data enters Python, Spark cannot manage the memory of the worker. So basically, it's using both the Java virtual machine and Python, and they are both competing for memory on the same machine. So it's sometimes recommended that you write your user-defined functions in Scala or Java, and then you just use the function from Python. So it will, if you write it on Scala or Java, the function, it wouldn't take any time, and it will be much better, the performance. But for doing this, you need to have both Scala and Python installed in the same machine or in your same workspace. And with partition and coalesce, you need to know whether to use one or the other. So coalesce, you say you want to combine partitions. Repartition, you will use it just if you want to create more files. And usually you don't want to create small files. So most of the files, they should be around 200 megs. If they are lower, then you can use coalesce to just combine those files and have bigger files. Because otherwise, the performance when reading your data in another, using either a Spark or another analytical tool, it will reduce the performance. So you can see a little bit diagram on how the Spark physical cluster works over here. Basically has a lot of slots on each executor, and the driver will send tasks to each empty slot on the executors when the work has to be done. So basically each of these tasks is like a partition, and each of these tasks will return one of the files that we were seeing here. And as I already told you, we have what is called the small file problems. So when you are writing lots of small files, there is a significant metadata overhead, and Spark does not do well with small files. So you will want to do a coalesce to put all your files together and do bigger files. And finally, you can find some references over here where to download the data that we use through the workshop. And there is also the PySpark documentation and some books, websites, also other tutorials that can be useful. And I believe I saw as well a workshop in Udacity about a Spark that is for free. So you can look into that one as well. So do you have any questions or anything before we wrap up this last part? Okay, so if there is no more questions, then I will pass it to Liliana again.
Awesome. Thank you. Let me just share my screen really quick to finish. Thank you very much, everyone, for attending. So just remember, if you know someone of you are interested to help us grow, we are always looking for leads with technical background and some leadership skills. And we are also looking for evangelists to help us to spread the word about how much this community is in need and certain other tasks. So if you have anyone of you, if you are interested, please let us know. Also, remember, we are in Twitter, we are in Instagram, and we are also in Slack. I don't know if everyone is in Slack. If you are not, you can also join us or ask me how you can join. And our handle is www.codepython for Instagram and Twitter. And that's all, guys. If you don't have any more questions on any concerns, we are good to go for the night. Thank you, everyone, for joining. Thank you, Aida, for giving us your time tonight and explaining us all of this. It was really, really interesting. We appreciate it.